very good afternoon friends, and in this video again we'll continue solving the questions from the exercise 9.4. We have solved the first 4 questions from exercise 9.4 CBSE standard 12. We are dealing with the solutions of differential equations. Now I am solving this question number 5. So here already have written the question here, that is e to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx is 0. Now I have to write this as e to the power x plus e to the power minus x dy equals e to the power x minus e to the power minus x dx. Then I write here dy over dx is e to the power x minus e to the power minus x over e to the power x plus e to the power minus x. Now, so with this is your function of x, there is no function of y, so that you can take it as 1. So here I write dy as e to the power x minus e to the power minus x over e to the power x plus e to the power minus x dx, and now I integrate both of them. So here it says it's already integrated. This is y equals. Now if you see, look at this term properly. Now we have done so many differentiation and integration, so we must have some little more confidence over the abilities of differentiation. So if you just look at this term and find e to the power x plus e to the power minus x, and if you take this as t, then differentiation of e to the power x gives you e to the power x plus differentiation of e to the power minus x gives you minus e to the power minus x. It means that if you take this as t, e to the power x plus e to the power minus x as t, then you get e to the power x minus e to the power minus x dx as dt. So what I am trying to say that you can write this as dt over t, and now on integration this becomes log mod t. So log, this is, so I write the next line, y is log mod t plus c. Now my final answer will be y is log mod t. What is t? That is e to the power x plus e to the power minus x plus c. This is the answer. In the textbook sometimes the answer may vary because this one can be simplified further. So in that conditions you don't need to worry, because any algebraical, trigonometrical or the exponential expressions can be re-refreshed into some other forms. So that is not a big issue. So I go to the question number 6. Question number 6. Question number 6 is dy over dx 1 plus x square and 1 plus y square. This is a function of x and this is a function of y. This needs to be with dx and this needs to be with dy. So I take dx there, so it becomes 1 plus x square dx, and this becomes dy over 1 plus y square. Now just integrate them. So what you get here, this is already in the form of tan inverse y. This integration of 1 is x plus integration of x square is x cubed by 3 plus c. This is your answer. Now I solve question number 7. Question number 7 goes like y log y log y dx minus x dy is 0. It means y log y dx is x dy, so dx over x is dy over log y. Now I have to integrate. So here you see that if I take, this is already integration, this is log mod x. Now if you take log y as t, log y as t, so on differentiation this becomes 1 by y dy as dt. It means this is nothing but dt by t, that is also log mod t, which can be written as log mod t is what? Log y. plus, since both the sides of the expressions are log, I would like to introduce my constant also in terms of log, so I write this as log c. Now this becomes log x is log m plus log n is log mn, so this becomes log c log y. Therefore what we get, x is c log y. This is the answer. Now I go for the next question. Question number 8. Question number 8 is x to the power 5 dy over dx is minus y square. So this becomes dy over y square is dx over x square. You can keep minus either here or here, and then I integrate. So the integration of this one gives you y to the power minus 2 over minus 2 plus 1 over minus 2 plus 1, and this gives you x to the power, sorry, here I need to write is 5. Okay, so this becomes minus 5. Okay, so I think I'm skipping one step. Let me write that also. Y to the power minus 2 dy is minus x to the power minus 5 dx. So that is y to the power minus 2 plus 1 over minus 2 plus 1, and this is minus plus 1 over minus 5 plus 1 plus c. So this becomes y to the power minus 1 over minus 1 is minus x to the power minus 4 over minus 4 plus c. So this becomes minus 1 over y is 1 over x to the power 4 plus c. So I can write this as 1 over x to the power 4 plus 1 over y plus c is 0. So for me this is a better expression, and that is my answer. Now I go solve next question, that is question number 9. Question number 9 is dy over dx. dy over dx is sine inverse x. Therefore dy is sine inverse x dx. Now integrate both of them. Then what we get here, we get y. This is, we just have only one function, so I take one more function, that is 1. So this becomes sine inverse x into 1 as another function. Now what I do that, I write sine inverse x unchanged, integration of 1 dx minus integration of d over dx of sine inverse x into integration of 1 dx, and everything integrated again here from this part to this part. So this becomes x times sine inverse x. I write it as x sine inverse x minus integration of product of differentiation of sine inverse x, that is 1 over under root 1 minus x square into x dx. Now if you see that if I take 1 minus x square as t, then what do we get? Minus 2x dx as dt. So x dx is minus half dt. So here this becomes minus half dt over under root t, and this is already integrated. So this is x sine inverse x. Now integration of 1 over t root 2, 1 over this root t becomes t to the power minus half with respect to t, and on integration this becomes t to the power half over half, that is 2 root t. So this is minus half into 2 root t plus c, and that is x sine inverse x. Now the final expression is x sine inverse x minus 2 and 2 cancel each other, and then it is minus root of, that is 1 minus x square plus c. This is my final answer, and here, yes, so this is this. So your answer is, and on this side we have y. So our final answer becomes y equals x sine inverse x minus under root 1 minus x square plus c. This question is also done, and then I go to the next question. Then I have question number 10, which goes like e to the power x tan y, e to the power x tan y dx plus 1 minus e to the power x sec square y dy is 0. Now I write e to the power x tan y dx equals, I take this on this side, becomes minus 1 minus e to the power x sec square y dy. Now I want to get rid of this minus, so I'll insert in between the bracket and get e to the power x minus y, e to the power x minus 1 sec square y dy, and this is e to the power x tan y dx. Now again we have to use separation of variable, so this dy is here, sec square y is here, we need to get tan y on this side, so this becomes sec square y dy over tan y is e to the power x over e to the power x minus 1 dx. Now it's already separated, so I simply integrate them. Now if you see, if you take d to the power x minus 1 as t, so you'll get e to the power x dx. So I directly write this as log mod e to the power x minus 1, and if you take tan y as t, then on differentiation we'll find sec square y dy as dt. So this is also coming in the form of 1 over something, 1 over like this 1 over tan y, and this is in the differentiation of tan y. So you can also write this as directly log mod tan y. Now this is log, this is log, so I would like to introduce my constant also as log. So this becomes log e to the power x minus 1 is log c tan y. So on taking the anti-log, what I get? E to the power x minus 1 as c tan y. This is my final answer. Now I go for question number 11. So this is question number 10. Question number 11 says that find the particular solution. Question number 11. Question number 11, this is the question number 11 set of question 4, 5 questions are there. It says the find a particular solution satisfying the given conditions. And what are the conditions? First one is x cube plus x square plus x plus 1 dy by dx equals 2x square plus x. Now since it is a particular question, it means that we should have the ways of finding out the constant of integration. So they have given you condition that when y is 1, x is 0. Okay, first let me integrate. Then what I get? Dy is 2x square plus x over x cube plus x square plus x plus 1. Now we have this part coming as dx. Now how to solve this question? Do you have any idea? If you remember, then this is coming in the form of the partial fraction. Like this is a polynomial of degree 2 and this is a polynomial of degree 3. Okay, so how to do that? First I have to simplify. I have to express this into some other form. So I'll go there, and here this is 2x square plus x over, from these two if I take, suppose here if I take x square common from these two, I'll get x plus 1, and if I take 1 common from these two, I get x plus 1. It means then next time I take x plus 1 common, and then I'll have x plus 1 and x plus square plus 1. So I'll write it directly. At the place of this you can write x plus 1 x square plus 1, and this is 2x square plus x dx, and this is also integration dy. So now let me get to the proper form. So 2x square plus x over x plus 1 x square plus 1. This x plus 1 is linear, so I'll write a over x plus 1, and this x square plus 1 is quadratic, so at the place of this one I'll write bx plus c. Bx plus c over x square plus 1. So I take the LCM, so I'm getting x plus 1 x square plus 1, and if I take the LCM, then what I get, ax square plus a, x square plus a, and if I multiply these two, I'll get bx square plus bx plus cx plus c. So I'll only compare the numerator part, and I don't have space also, so I remove this extra useless thing, that is 2x square plus x equals. Now compare or regroup the coefficients so that the like terms come together. So I get a plus b x square plus, we have bx plus c, b plus c x plus, we have a plus c, and that is 2x square plus x. If you compare the coefficients of the like terms, so it's x square coefficient, here is a plus b and 2 is here. So what do we get? A plus b as 2. Here it is b plus c. So b plus c is 1, and here a plus c is 0. So if a plus c is 0, then c is minus a. So in this equation, if I write the c as minus a, so this becomes minus a plus b as 1, and this is a plus b as 2. If you add them up, you get 3b equal to, 2b equal to 3, so b equal to 3 by 2. So b equal to 3 by 2, and then the a will be 2 minus b. 2 minus b, that is 2 minus 3 by 2, that is 4 minus 1, that is a, we are getting as 1 by 2. Now you see c is minus a, so your c will also become minus half. Okay, so what we get? We get, at the place of numerator I write a over x plus 1, and a is half. So this becomes half 1 over x plus 1 dx. Now I go for this bx plus c. So bx plus c, I'm getting this bx as b as 3 by 2. So I separate here also. I would like to write bx upon x square plus 1 in one term, and then c upon x square plus 1 in another term. So this becomes b. So b I write outside, that is 3 by 2, and this is x dx upon x square plus 1, and c is minus half. So this is minus half integration 1 over x square plus 1 dx. Now let me remove this part of screen. So here, if I integrate, then integration of 1 dy becomes y, and this is half. Integration of 1 over x plus 1 becomes log mod x plus 1 plus 3 by 2. If you take x square plus 1 as t, you'll get 2x dx. So just 2 I write somewhere outside. So it becomes half, and this also becomes log mod x square plus 1 minus, this is 1 by 2 tan inverse x. Okay, and then I need c, that is the constant of integration. But since, if you see here, this case you are given y is 1, it means 1 is, at the place of x you write 0. So log 1 is also 0, gone, and this is also log 1, gone, minus 1 by 2 tan inverse x, that is 0, that is also gone, plus c. So you are getting c also as 1. So in this expression, if you finally replace your value of c as 1, then this becomes particular solution. If c remains c, that is called the general solution, and if c becomes 1, it becomes a particular solution. This is how this question 11 will be solved. Now I'll take the question number 12. Question number 12, it is x square minus 1 dy over dx is 1. Then again you see, we can write this as dy 1 over x square minus 1 dx, and then you have to integrate this part. Now this term 1 over x square minus 1 can be written as 1 over x square minus 1 can be factorized as x minus 1 x plus 1. So this is x minus 1 x plus 1. All these three terms are linear, so we can have a over x plus b over x minus 1 plus c over x plus 1. If you take the LCM, then you get x plus 1 x minus 1. This is a x minus 1 x plus 1 plus b x plus 1 plus c x minus 1. Now, and this is 1 over the same thing. So I remove this denominator because we have to compare this coefficients only, and actually our task is to convert this secant. This is a rough work also. So now here if I take that, let x is 0. So if x is 0, this part vanishes, this part vanishes. 0 plus 1, 0 minus 1 is minus 1, so a is minus 1. If you write x is 1, so 1 minus 1 vanishes, x minus 1 vanishes, 1 and 2, this is 2, b is 1, so b is half. So b is just half. If you write x as minus 1, then this part vanishes, this part also vanishes, and this minus 1 is minus 2 multiplied by minus 1 becomes 2, so c is also just half. So c is half. So this expression becomes a, that is minus 1. So here I have my dy intact, and at the place of integration of this I will be integrating these three terms together with the value of a as minus 1, b as half, and c also as half. So this becomes minus 1 over x dx plus half integration 1 over x minus 1 dx, and then plus half again integration of 1 over x minus 1 dx. Now I remove all these useless things because this job is done. Here if I integrate, this becomes y, this is minus log mod y, plus this is 1 by 2 log mod x minus 1, and 1 should be plus, I make this is plus, x plus 1 plus 1 by 2 log mod x minus 1 plus c, that's constant of integration. Now we have to find the particular solutions, means we have to put the given set of values to find out the value of c. Now what are the given set of values? It says that y is 0 when x is 2. So y is 0 when x is 2. It means this is 0. Now this is log x, sorry. Now minus log 2. Minus log 2, fine, we need this value. This is plus log 3. Plus log 3 means half log 3. And this is 2 minus 1 is gone, it's not required. Plus c. Then c is, this is log m minus n. So this is under root 3 by 2. So value of c is 0 equals, this is what root 3. So log root 3 over 2 plus c. So what is c? c is minus log root 3 over 2. So now in this expression, if I replace the value of c as minus log root 3 by 2, this whole expression will become a particular solutions of this given differential equation, and this question is also done. Now this is question number 13. This question number 13 goes like cos dy over dx as a. Now you know that if you write dy by dx, this becomes cos inverse a. So dy is cos inverse a dx, but cos inverse x is constant, so it means we have to integrate like this. So what do we get? We get y equals x cos inverse a plus c. Initial conditions given as y equal to 1 when x is 0. So when x is 0, this part is 1, and then y becomes, this becomes 1 and this becomes c. So c you are getting as 1. So our equation becomes y is x cos inverse a plus 1. This is our answer. Now we have dy over dx as this, dy over dx as y tan x, and y is 1 when x is 0. Okay, so I write dy over x, take this tan x, so take this y down, so dy over y is tan x dx. Now integrate. What is integration of 1 over y dy? That is log mod y. Integration of tan x is log sec x plus, since both these are log, so I introduce my constant also as log. So I get log mod y is log mod b plus log mod constant, that is log mn. So c sec x. Okay, now take anti-log and then you find y is c sec x. This is our general solutions. Now if you put this initial condition that if y is 1, x is 0, so it means if this is 1, x is 0, so this is c sec 0. Sec 0 is reciprocal of cos 0, that is 1. It means c is also 1. So here 1 is c. In this expression, if I put the value of c as 1, this y is sec x is the particular solutions of this given differential equation. So now thank you very much, and in the next video we'll take some more questions.